Identify any vertical asymptotes, horizontal asymptotes, and holes for the function f of x equals x minus 2 all divided by x squared minus x minus 6. Well, to find vertical asymptotes, horizontal asymptotes, and holes, it's often helpful to factor the function completely if possible. That's means that we take the numerator and factor that polynomial, and we take the denominator and factor that polynomial. So let's try and factor x squared minus x minus 6. We have an x and an x. We need factors of negative 6 that add together to equal negative 1. Those factors are negative 3 and plus 2. And so that looks like the factorization for this function. You can multiply it out to double check. That tells me several things. First, I can look in the denominator to find vertical asymptotes. Vertical asymptotes will occur any place that the denominator is 0 but that the numerator is not 0. And that those numbers are x equal 3 and x equal negative 2. Both of those will produce division by 0 that won't be compensated for by any zeros in the numerator. So vertical asymptotes at those two x values. Holes occur anytime that we have 0 in both the numerator and the denominator. This has no such factors. There are no factors that match up in the numerator and denominator, so there are no holes. And to find horizontal asymptotes, we can look for places, or look for rather the relative degrees of the numerators and the denominator. So this, if we were to multiply this back out, we'd get back to our original function f, and we see that the degree of the denominator is 2. That is because we have an x squared. This exponent of 2 makes the degree 2. The degree of the numerator is only 1, and so whenever the degree of the denominator is greater than the degree of the numerator, we will have a horizontal asymptote of y equals 0. And we can see that by taking our original function f and rewriting it by multiplying the top and bottom, rather dividing the top and bottom, the numerator and denominator, by the highest power of x that we see. And so if we do that in the numerator, we would be dividing by x squared. And x divided by x squared gives 1 over x. 2 divided by x squared gives 2 over x squared. We have to subtract those. The denominator, when we divide everything by x squared, gives us 1 minus 1 over x minus 6 over x squared. And as x goes to plus or minus infinity, the terms 1 over x and 2 over x squared each become vanishingly small. Likewise, for 1 over x and 6 over x squared, those become vanishingly small and approach 0. And f approaches 0 over 1, which is 0. And that is the reason that our horizontal asymptote will be 0. This type of behavior would occur anytime the denominator had a higher degree than the numerator, because we'd have a constant term here. The numerator would have one or more terms that all went to 0. And so we have a horizontal asymptote at y equals 0, and two vertical asymptotes as noted here.